Hi everyone, Professor Bob Young here. In this instructional video, we're going to discuss polynomial functions of higher degree. So I've got some notes up here and some graphs, but what I wanted to do first is go to our graphing tool desmos.com and then we'll come back here. All right, so I went ahead on Desmos here and I typed in the equation y equals x squared, and I want y'all to start watching something here. Watch when I make this x to the fourth power, x to the sixth power, x to any even power. There's the 12th power. Notice the parabola, it looks like the nose is getting flatter and flatter. Now in class I'd say it looks like someone punched this thing right in the nose. All right, but what does happen is this thing always, it's never a straight line across here. So in other words, no matter how high this power is, this parabola is always going to be decreasing from this end till it gets to zero, and then it begins increasing along this path. So we're going to talk about some different things here: increasing, decreasing, constant function. So notice any parabola with an even power kind of reminds me of my friend y equals x squared, which we will show as our common function that we did in chapter 2 a lot. Now, what happens here? What if I put a negative in front of a function, negating a function, whoop, flips it about the x-axis. And again, as the power gets higher and higher here, watch when I make this an 8, or if I make this a 12, that nose gets flatter and flatter and flatter here. So what I want you to remember in this section, if there is an even power involved, you're going to have a parabola. And it could, just like we did in section 3.1, it could either smile or frown. All right. Now, one other argument, Young, what if it's not an even power? What if it's an odd power? I knew you guys would ask. Now, there's our friend, the cubic function y equals x cubed. Now, watch what happens as this odd power gets higher and higher and higher and higher. It kind of looks like, again, the middle here is going to be a flat line, but it is never going to be a flat line. This part right in here is going to be increasing all the way from negative infinity to positive infinity. So notice this graph, if you go on the x-axis, it always has a positive slope as it progresses. So it's going to be increasing forever. So this graph never decreases. All right, now what happens again if we go back to our basic one, y equals x cubed, and we negate it? It reflects it, whoop, about the x-axis. And again, as the power gets higher and higher and higher, we'll go 5, we can go 9. So this is a great graphing tool, Desmos here. You can kind of see what happens as we go along. All right, so here's a few illustrations here in the notes now. I put y equals x to any even power. So if you want to, I mean, you can come over here and put a few examples like y equals x to the second power, y equals x to the fourth power, y equals x to the 12th power. And remember, the higher the power, the flatter this nose gets. Also, the higher the power, the quicker this thing shoots up on the y-axis. So for example, if we're looking at y equals x squared here, think about this for a second. We would let x be 0, y be 0 to get our points. If we put in 1 for x, we'll get 1. 2 will get 4, and so forth. But let's compare that with, let's say, the second one, y equals x to the fourth power. 0 to the fourth would still be 0, 1 to the fourth would be 1, but when you put in 2 for x, this thing starts skying on y here, and think about if it was the 12th power, that thing would go up super high. All right, so notice this graph here, it's decreasing on x from this interval. So on x, we'll put negative infinity to 0. And remember, increasing, decreasing, constant always has parentheses. And it starts increasing. Although this looks flat, it is just barely, going upward. And it increases from 0 to infinity. All right, now again, we could play the domain and range game here on this one. The domain, if we wanted to put that, and we could do this on all of them just for good practice and review. All x values, this would go from negative infinity on x to infinity. Similar to our quadratic functions in the previous section. Range would be from 0 to infinity on y. So on y, this starts at 0. And remember, this includes 0. So on this one, you would have to put a bracket on 0 and then close it to there. All right, so notice the frowny parabola. If you just negate that, and it's still an even power, so if you wanted to put some examples here, you could put y equals negative x squared, y equals negative x to the 10th, and so on and so forth. So what we're doing in this section, we're kind of putting our functions in this format. F of x equals ax to the n power. We're just looking at these higher degree polynomial functions in this episode here. So notice this one increases along x here from negative infinity to 0, and it decreases from 0 to infinity. And the domain would still be all real numbers, and the range on this one, so if we wanted to put domain here, we could. Good final exam review as well. Still got some students having issues with domain and range, which just means x and y values along the graph. The range on this one comes in on y from negative infinity and stops at 0, but it does include 0. So again, be careful on these. All right, let's consider odd powers. Now, whenever you have an odd power, you can write y equals x cubed, y equals x to the 7th, y, and so forth and so on here. But again, as the power gets higher, this gets more and more level, or it looks like flat here, but it never is. But if you count this from x, from left to right, see, notice this is increasing along x, keeps increasing, that slope stays positive. And this thing keeps going upward. So all along this thing is always going to increase when you have one of these. So it's going to be from negative infinity to infinity. And then this one, if it's got, let's say, a negative in front of it, which reflects it about the x-axis, and we could put a million more of these in here. I'll get really fancy and creative here. Try to put that one in Desmos. All right, this one will always decrease. So they will ask you this in the homework as well. And of course, we're going to look at some homework problems like Young always tends to do here. So let's jump in the homework and look at some of these in section 3.4. There's not a lot of problems in 3.4. All right, so here is number 1 here on the 3.4 homework. It says, graph this polynomial function y equals 5x to the 4th power. Now, hopefully, since that's an even power, you're going to throw choice D out right away. So if anyone chose D, I would be worried. Also, note that this one will smile here because that's a positive number. So, or open upward, as the textbook likes to say. I like to say smiles or frowns, and it would go through the origin when x is 0, y is 0, so that would certainly look like to me be choice B here. And we definitely got it. Bang, as I like to say in class. Now, this one's going to ask you some things here. Its thing is going to say, where is this graph increasing? And I would say this part right here on x is going as a positive slope here. So I'm going to say increasing from 0 to infinity. And you might want to do your copy and paste thing here as you do these. All right, good. And then decreasing, it would be from negative infinity to 0. So we kind of talked about that on the early lesson there. So I'm just going to have to flip this around. Negative infinity to 0, and that will be the first answer. All right, continuing. This one here, I'm going to let y'all do some of these as we go. Notice this is negative 16x to the 5th power, so it's odd. So I would say it has to be A, C, or D. Now notice I would pick A on this one because again, this one D looks like it's gonna shift upward some. It looks like, and we're gonna do some with shifting in there too. I know y'all can't wait for that. You definitely have to throw out B here because if it's an odd power, it's not that one. So on this one, we'll go ahead and choose choice A, and we'll do a few more here. Now it says, where is this graph increasing? And notice this has a negative slope on x from negative infinity to infinity. So on this one, we're going to have to say, hey, that one does not increase whatsoever. And it decreases from, and I think this is the one I want to copy and paste now because then I can alter this one a little bit better, negative infinity to infinity. So I'm going to hit Control A, Control C there, and then another one in the bag. Now notice I didn't give you a lot of these, so, you know, don't panic and so forth. And then you'll get really quick at doing them. Now here is one that's got a shift on it. Now let me see if I can find some that shift even more. Now here is one in my math lab that they want you to graph in my math lab. All right, so what I think I'm going to do is to, let me see if I can go back here and come back this way. All right. Let me go back here and let's look at some of those other ones real quick. Now, since this is an odd power, and this number's positive in front with a +2, I would think, well, that's going to be an S-shaped thing, so it could be B, C, or D. But with that +2 there, notice if X is 0, Y will be 2. You should note that this thing will shift vertically 2 units up. So right away, see, some of these you'll just be able to look at and knock them out, and then those won't be difficult at all. And then they're going to do the increasing, decreasing constant stuff here on you. Now this graph is always increasing, okay, from left to right. So see, if you've got your copy paste feature going, bang, and then it never decreases. So just put B on that one. Okay, now this one would be shifted here. So I tell you what, let's pause and I'm going to write this one down, and we'll do it both in my math lab and on graph paper. All right, so on this graph, I hope everyone remembers from the previous lessons that this graph is going to be S-shaped, and with the negative here, it should be S-shaped in this manner. All right, so just from whether this is positive or negative and this is even or odd can tell us a lot. Also, this graph should shift vertically up 2 units and to the left 1 unit. And if you're not sure about your shifting still, if you go left 1 and up 2, this is the point I want to check -1, 2 and make sure it makes sense in here. So ask yourself, if I put -1 in here for X, will Y be 2? And I think you're going to find out, yes, it will. Okay, so try that out. Now also we need how many points here to graph a parabola, a cubic function or any odd function. We like to have at least 5 here. So I'm going to go ahead, since I know where this X value begins, and I'm going to put a few more values in here for X, and then we'll check on them. All right, so I'm back here, and notice I went ahead, since X was -1 at this shifted point, and this is why shifting is so important, I went ahead and I put in some values of X to the left and right of this. So I put a 0 in for X here, and when I did that, Y came out 1. When I put in 1 for X, Y came out, and I may have to adjust this just a tad to get it, -6. And you can see that this graph is taking on the appearance we set up there, -2, 3, and -3, 10. So if we were going to do one of these in class and I had you do it on graph paper, it would look like this. Now connecting the dots on this on my slippery writing tablet does not look pretty. So there is the graph as I promised it would look like this. All right, but let's go back to my math lab now, since you're going to be doing a lot of your stuff in there, and we'll show you what to do there. All right, so on this one, let's just do the one we just graphed here. I'm going to pick the cubic function, and I think most of you would probably start at that point we did, -1, 2. So I'll go ahead and put that point there. All right, now notice this one's going to make you graph 5 points just like we did. So I'm going to put 0, 1 in there. I'm going to put 1, -6, and this thing's going to do all kinds of fun stuff till you get it the way you need it. And then we'll put in, what was the other point? -2. And you can have some fun when you do this. You can go 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. You guys got to have a little more fun when you do these graphs. -2, 3. And then it looks like it just had me do 4 points, but it does look like the -3, 10 it's going to run through there. So check it, bang. Okay, so we're well on our way to doing these. Now, is this one increasing? No, because it's going in a negative slope direction on X from left to right. And then they're going to keep playing this game with you. It's always decreasing, as we talked about earlier in the lesson. So the nice thing now is you can stop, pause, rewind, fast forward me and go back and say, what did he talk about earlier? All right, and there we go. All right, now the last thing to finish out the lesson is in your supplemental handouts here in Canvas, and this is talking about the end behavior or leading coefficient test. All right, now notice when you go to do these, you're going to get one of these 4 answers right here. So let me see if I can look at this here. So when I look at now, when you guys take pre-calculus and higher level courses, you're going to get a whole bunch of other things mixed in the graphs with these. All right, so we can take this first one. I'm going to write this down and put it in Desmos, and I want to show you something real quick here, and we'll come back to this. All right, now looking at this graph, I typed in that first equation here. What happens in pre-calculus is you have graphs that will do all kinds of things. They might have turning points, what they're called. They'll go in all different directions and loop-de-loop and everything. But notice this one on the ends goes upward. So what I'm going to point out here is that whenever that power is even and this number in front is positive, this graph right here is going to remind me of my friend y equals x squared. So let me go back to the notes. All right, so in pre-calculus, they'll call this the leading coefficient test or possibly end behavior. So what you do is you look at the highest powered term in each polynomial, and then since this is even and that's positive, what I want y'all to remember, no matter what they do, is this reminds me on the ends of y equals x squared. All right, notice the second example. If that's even and it's negative, that kind of reminds me of y equals -x squared. And they're going to have some problems in the homework, and I'm going to put a few of these on the test. Y'all will love it just to answer which one of these 4 it is. All right, the third one is y equals 2x to the 5th. I want you to remember our friend y equals x cubed on the ends. This one kind of looks like it. Now, if you wanted to put some more of these in Desmos and look at them, you would see what they do on the end of the graph would be exactly this. You know, it might do, you know, this one might on Desmos do a whole bunch of loop-de-loop and stuff. I mean, they might even do this when you get to pre-calculus. They'll call these different points here turning points and local minimums, local maximums, all kind of things involved. But on the ends, it's going to look like our friend y equals x cubed. And notice here, that one's going to reflect about x. It's going to look like our friend y equals -x cubed. So you'll be able to go through here and blow out the rest of this homework very quickly. Alrighty, back at you here. Now here's some more homework problems. This one, all we care about is that, let me see if I can blow that up just a tad for you, y equals 5x to the 5th power. Now this one reminds me of which one? Yes, our friend y equals x cubed. So some of this homework will be very quick in this section. -6x cubed, which one would that be? Reminds me of y equals -x cubed. So again, if it's an odd power, S-shaped, even power, parabolic shaped, here we go. This one, 7x to the 6th power. I know some of you are thinking, put a lot of these on the test, Young. Put a lot of these. It reminds me of y equals x squared, our parabolic friend. I did put several on the test, you will see. All right. And the last one, oh, look, they tried to trick y'all. They've got the highest powered term last. Are you afraid? Are you going, mama, mama? No, don't be afraid. So this one will be the parabola going downward on the ends. All right, so that concludes my lesson on polynomial functions of higher degree. Remember, this is my new Las Vegas Raider hat. Just win, baby. Be Young signing out.